This is a 2018 BC free response question number 1. Okay, the question is, people enter a line for an escalator at a rate of r, which is modeled by this expression between 0 and 300. And the expression is really complicated. And people exit the line at a constant rate of 0.7 person per second. And there are 20 people in line at a t equal to 0. So I drew a little picture here to illustrate what the question really means. That means when t equal to 0, you have 20 people in line on the escalator. And the rate for people to enter the line is r of t. On the other end, you have people leaving the line at a 0.7 person per second. The first question is, how many people enter the line for the escalator during the time from 0 to 300? The first question is a simple integration problem. So the number of people entering the line should be equal to the integral of the rate, entering rate, r, from 0 to 300. The tricky part is that you may have to really make sure you enter this expression into your calculator correctly. I copied those two rates over here just for me to use later on. I also defined the function n, capital N, to be the number of people on the escalator. N of 0 it equals to 20. The second question is, how many people in line at a time equal to 300? I defined another function, small n, to be the rate of people in line. The small n of t should be equal to r of t minus 0.7. And the total number of people in line should be equal to the original people in line, which is about 20, plus the how many people actually entering the line minus the people leaving the line. So it's the integration of the small n of t from 0 to 300. The first part is how many people entered the line. The second part of the integral is how many people left. So you can just calculate those two integrals and you will get the answer as 80. Don't forget about the initial condition in this case, which is n of 0. More than often you don't remember to add this number to the total. The third question is, at what time, the first time, that there's no people in line for the escalator? After t greater than 300, there's no people coming in, but only people who leave at the rate of 0.7 person per second. We try to find the time t such that n of t equal to 0. That means at that time, there's no people on the escalator. So n of t, the capital N of t equal to capital N of 300 plus the integral from 300 to t. Now the rate at this point is only the leaving rate, which is negative 0.7. And the entering rate equal to 0 because nobody coming in. When you simplify this equation, you will get 80 minus 0.7 times t minus 300 equal to 0. Solving this equation gives you the t equal to 414.286 seconds. That is, at a time t equal to 414.286 seconds, there's nobody in line. Obviously, when t greater than this number, there's nobody in line also. So this is the smallest number for t, that there's no people in line. The last question is, what is the time when there's a minimal number of people in line? This is the minimum maximum problems. And what you really need to do at this point is try to find the derivative of the capital N, which is the small n of t, and which equals to the r of t minus 0.7. And when you set this in equal to 0, this will be the critical point for the capital N. The best way to do this is probably enter the small n of t into your calculator. So I wrote something over here. So you assign this whole thing equal to y1, and make sure you entered the expressions correctly. Otherwise, you will not get the right answer. Then you graph this derivative, which is y1, and you try to find those 2 points. And one of them is t equal to 33.013. The other one is t equal to 166.574. At those 2 points, the derivative of the capital N equal to 0, and those are the critical numbers. Now I'm making a chart to display all the numbers. I also have to include the 2 endpoints. One is 0, the other one is 300. And then I try to find what is n of t, which is given by this expression. So the initial condition plus the net rate going from 0 to t. You integrate this whole thing. The initial condition we have is 20. And this at 300 we got from previous questions 80. Now for the other two, those two are the critical numbers. And the best way to, or easier way to solve the problem is just plug into the calculator. Plug in the y1 into the calculator from 0 to 33.013. And plus 20. Don't forget about the initial condition. So this gives you 3.803 roughly is about 4 people. And by the same way, you can calculate this one. So instead of integrate from 0 to 33, you integrate the whole thing from 0 to 166. So now you compare all those 4 numbers, and this one is obviously the smallest one. So you can answer the question to say when t equal to 33.013 seconds, about 4 people waiting in line.